Hey guys, and welcome back. So this is our ground geometry, and let me template a few things, or just this. And I know that the main destruction is going to happen here. And let's first take a look at investigate the geometry. So this is the ground. Everything is separate piece, separate geo. And let's put down a connectivity. I know I have a lot of attributes on this guy, but let's ignore all of that. I'm just gonna create a name attribute. I'm gonna call this ground. And I'm assembling it right now like it is, with no fracturing or anything. And then I'm gonna generate a random attribute based on that. Cool. So you can see we have individual pieces, and I know Kong is going to be coming from this area, and I want to fracture these guys more. I want to keep everything the same. I'm not going to fracture this too much, but where Kong is going to be pushing his feet, we're going to have more details there. Maybe I can show... Yeah, I think I can show the original geo. Pardon me. So I'm writing out the original fractured one. Okay, let's import it. I moved it up. Maybe you should do that as well. Okay, and let me import the original sim. Transform pieces. I want to show you guys how it looked like. Maybe... No, there is a separate one for the ground. And I'm gonna find it in a second. Okay, let's try this. Cool. So this is the cache, and you can see we have more fracture here. All these guys are the same, and that's basically... Actually, maybe I want to press this as well. So that's pretty much it. We're gonna fracture a certain area more than the others. And for the constraint, I only used a glue constraint here just to hold the pieces together, and it was a very weak glue constraint. As you can see, once there's a tiny bit of movement, it starts breaking and falling down. And the way I got this radial effect is by putting the ground above this ground, above the collision. Do you see that gap there? So when a piece, when the constraint breaks, it just falls down like this, which creates this cool radial collapsing effect. I know it's not visible but in the final render, but it is there. Okay, so what do we need? We need a few things. First of all, we want to isolate an area. So we made a name attribute. I'm gonna assemble this, and I'm gonna pack these guys. I'm gonna put down a delete node. I'm gonna delete by region. Okay. And this area. That's what I'm gonna appraise. Everything else is gonna stay the same. So base. I wouldn't say appraise, but to fracture. delete non-selected, and then we can just use a Voronoi fracture here, nothing crazy. I'm gonna scatter generate a volume from this, scatter some points, and that's it. You guys can go fancy with the fracturing here. Shouldn't be taking too long. So what actually we have to unpack the geo first, which is done automatically in certain cases. But another thing that we have to keep in mind is it's we don't have a lot of attributes. Okay, so it's very important when we fracture the geo to have the least amount of attributes, because the Voronoi fracture is going to try and keep those, and the more attributes we have, the slower it's going to be, and the more memory it's going to use. So let me check what's happening here. Don't have a lot of points. Let me try something super quick. I think it's fine. Okay, let's visualize pieces. Okay, I think we can increase the number of fractures, but what I want to do is I want to actually fracture only when the feet are crossing, when the feet are intersecting with the geometry, because that's the area that I'm mainly interested in. And for that we need to trace or track the feet, conch's feet, and we're going to do that now. So let's go back to the sim. So I have this. I don't need this guy. I need this. This is the geometry I need. And what I'm going to do is I'm going to put down a VDB from Polygon, convert this into I don't need the subdivided version, and convert this into a density. It can be a low res one, and I'm going to scatter points. And let's increase the number of points. Okay. I'm going to I don't need to keep everything, so I'm going to blast anything that is below 1. 1 is fine, I think. So if the height is less than 1, I want to delete the points. 5, let's try 10. Yep, something like that. And I want to accumulate this result over time, and for that I'm going to use a SOP solver, and it's very, very simple. I'm going to dive inside, and we're simply going to merge the previous frame with the old frame, with the current frame. And by doing that, if we hit play now, it's going to keep accumulating the result over and over, and now we're tracing conch's feet. And the points are too much, so let's lower this to 5,000. Let's reset this, and let's check where is our geo. This guy, and I'm only interested from frame 18 up until 140, 150. Okay, so we'll do 15 to 150, and I don't need to store all of this into disk. I don't need the full sim. So feet that, and I'm gonna set this to 150 and 15. I'm not gonna give it a dollar frame because I want to keep overriding this frame over and over. So if we hit save now, it's gonna start going, and every time it's accumulating and overriding this frame, overriding up until frame 150. We could definitely do a sequence if we needed to. I did this previously, but I didn't use the sequence, so that's perfectly fine. Okay, and now we have that. Let's copy this and let's go to here. And we don't need all these points. So I'm going to use another, I'm going to copy that blast that we did and lower the value. I store more just for safety reason. So something like that. And I'm going to lower this to 100. And I'm going to use a point replicate on these guys. So the right feet. Okay, so we need a higher value for these guys because the right foot seems to be higher. So I'm gonna just select these guys. Let's separate them. So X is less than 10. I don't recommend doing this because this long list can increase the file size, but it's okay for now. So I separated both, and this guy we're deleting at that level, maybe 2, yep. And then this one I need to transform it down a bit because it's too high. Something like that, and let's merge them. And delete. Okay, cool. So let's do a point replicate 10. Sphere, increase the sphere size. And I think we have a lot of points, so let's delete 50% of them using this. If rand at ptnum is going to generate a random number based on the point ID, and then the less than 0.5, this guy generates random between 0 and 1, and this is going to give us 50% of the points. So delete 0 at ptnum, and now we have 50% less points. And we can replicate, maybe even keep 10%. Sorry, we need to increase this 20%. Okay. Something like that. And let's merge this. With these guys, and let's fracture. And I'm not gonna finish this, I'm gonna just fracture it. You guys know the rest. We just make a constraint network for this, add the RBD object, and add it to the system. There's nothing crazy about this. The only thing that bothers me a bit is why this is slow. I'm not so sure. So I'm gonna check something. If we have individual geometry, why not we loop over each one of them and fracture it individually rather than dealing with the whole geo like this? And I'm gonna check the Werner fracture. If it's not doing that, then if it's not basing this on the connectivity, then there is a way for side effects to improve this node. Transfer attribute, triangulation. Yeah, it's not doing it for each. Okay, so let's do it ourselves. So for each connected piece, okay, we want to Voronoi fracture this. And now it's going, but we don't want to use a for each loop just like that. We want to use a compile block to make it multi-threaded. So this, and then this, and we need to copy this guy for the second input, and then we need to copy this for this input. Fetch input, and let's turn on enable multi-threading, and let's see. Maybe there's some issues with the geometry. Yeah, it shouldn't be this slow, so I'm gonna do some investigation. No, it's fast. Okay, so it finished 50%. It's definitely faster. Yep. But I still feel that the geometry, there is something with the geometry. So what we could do is we can go over each one, each piece, and just fuse it and clean it. And let's do another assemble because the name attribute is not correct at that level. It's the same. So we'll call this ground final, and let's generate a color based on that. Cool. So you see we have a cool fracture here. Maybe we'll increase the outer points, and inside this I'm gonna, yeah, the geometry is fine. I'm gonna do a fuse to make sure that everything is fused, and I'm gonna do a clean, and let's increase the number of points here to 1,000. And this I'm gonna reduce to 6. Let's take a look. Maybe it's a bit faster than before, but we also reduced the number of points. Yeah, I think it's fine. I mean, we're only talking 30 seconds here, so... Okay, so we fractured this, and I think that's pretty much it. I'm gonna plug this with the other stuff, the static stuff. So let's merge. And let's make sure we have a name attribute. I'm gonna assemble this again to make sure that I have a name attribute, and I'm gonna call this ground static, or not static but base, and then let's merge this with this, and then we create a connect adjacent pieces and connect all these guys. Yep, that's it. And it's not connecting it's not connecting these. So let me delete this name attribute. Connecting, but it's not connecting between the centroids. So let's check something. Don't have. Yes, I know what's happening. So here we have a packed fragment, and I need to unpack all this first. So unpack that. We have a name attribute. I don't need that. And then we regenerate the name attribute again. Make sure that we have something unique. And now if we do the connect, and let's reset this, we have our network. And again, stuff like this it can be really frustrating to find it and figure out what's happening. So this is where practice comes in. You can figure out things quickly, and if you fully understand the workflow, it's going to be really easy to debug these things. So this goes into our network, constraint network, and this is into the RBD object. I'm going to use a glue constraint for this. I don't need anything fancy, I just want the pieces to get pushed in the form. And I think that's pretty much it for this week. I really want to add this though. Okay, let's do it. Let's do ground glue, and let's put down a null. Pardon me. And it's going to be ground RBD and ground CST. And let's set up some inactive stuff to hold everything together. Otherwise it's gonna fall. It's gonna be floating above the surface, above the ground geometry. And that inactive stuff is here. Let's copy this. And we have to make sure we have a packed geo. Okay. Let's take a look. So all this is inactive, and all of this is inactive. Okay. Copy this, go to the RBD object, and for now I'm gonna leave just one impact, or maybe two impacts. And this I'm gonna set to, yeah, let's leave it at 0.5. And remember, we added a 25 multiplier based on that, on the length. So remember, we have 1 and 5. Yep. So this, I like these three. I like that one. I'm gonna remove this one, the big one, that's all. I don't want to deform that main wall. And I will multiply this down by 25 here, so the ratio stays the same and I don't have to, let's actually divide it by 25. And so it stays relative to the previous example. And let's go back. RBD object, ground, that's our ground geo. We'll set the mass to 100, and let's create a constraint network. And I forgot the name of the node, but I know it's a glue constraint. So let's check the name again. And I want this to be really weak. I want it to be really weak so that anything will cause it to collapse and start moving. So let's check. And that's our glue constraint working. I don't need any deletion there. I'm gonna introduce Kong. Obviously we have to add a T-Rex as well, but that's pretty straightforward. I think you guys can do that. And I'm gonna go up. We added the ground, So let's add that. And I'm gonna save this as ground final. And 120 frames, V21. And I think that's pretty much it for this week. We'll take a look at this result. Maybe it's gonna work, maybe not. We'll see. And that's it. Thank you guys for watching, and see you in a bit.